Hello students, in this session we will see sums related to units and measurements chapter. You should be clear with all those concepts that we have studied in units and measurements thing, okay? The concepts that we studied were propagation of errors. You get question from propagation of errors, okay? You should be clear with that part. Then you have like dimension analysis, right? So you get questions from dimension analysis most often. But the thing is you need to know the formula to do the dimension analysis, right? So majority of the question related to dimension analysis will be solved in that particular chapter. For example, if you take laws of motion, there are questions that comes related to the formula from the laws of motion. So those dimension analysis question will be done in the laws of motion chapter, okay? So we don't do much about those questions in this session, okay? So that is not needed, fine, but we will do all those questions in their respective chapter, right? So you need not worry about that one. Then the main part is like vernier caliper and screw gauge. Most often you get question from either one of those two topics, okay? So we will do all those sums also, fine. So this is going to be one of the shortest sessions because you'll have only around like 14 questions, right? Because we will leave some of the question, around 10 questions that is related to dimension analysis, which will be dealt in those respective chapters that is about to come, right? So let's jump into it. Let's see the first question, that is from screw gauge. Let's see what the question actually is. A screw gauge has least count of 0.01 millimeter and there are 50 divisions in its circular scale. Fine. So what they have given us, they have given us the least count directly, which is 0.01 millimeter. And same way they have given the number of divisions on the circular scale. Fine. So what we are supposed to find is the pitch of the screw gauges, right? So we need to find the pitch of the screw gauge, right? So in order to get the pitch of the screw gauge, we need to know the formula for the least count. Least count is nothing but pitch divided by number of divisions in the circular scale, right? So we should know the concept already because we have discussed that in the theory part. So we have like pitch divided by number of divisions in circular scale, right? So that is what you will get it. So number of divisions in circular scale, right? So in order for pitch, what they have given us, they have given, that is something that we need to find, right? So least count is something that is given, which is will be like 0.01 millimeter. So least count is already known, 0.01 millimeter. So we should stick on to that convention, right? So here they have given in 0.0 in millimeters. Therefore, the pitch should also be measured in millimeter, right? So the answer that you are going to get for the pitch will also be in millimeter, right? So that is matched. So we do not need to worry about the unit conversion and those things because it is straight away. It's matched, right? It should be pretty obvious. Then which is equal to pitch. So that is something that I need to find divided by number of divisions in the circular scale. So number of divisions is obviously 50, which is in the question. So you do the cross multiplication. So when you do the cross multiplication, you will have like pitch, which is equal to 50 into 0.01, right? So that will also be in millimeter, right? So when you do the math, you get like 0.5 mm, right? So the answer is like 0.5 mm, right? Fine, one, yeah, right. So the answer is option 3. Fine. So these are simple questions which you should know. Let's move to the next one. Next sum is related to propagation of errors. Let's see what it is. In an experiment, the percentage of error occurred in the measurement of physical quantities A, B, C and D, right? So they have given me the percentage error, which are like 1%, 2%, 3 and 4% respectively, right? So A will be matched with 1% and you should match B with 2% and then it goes on, right? So that is what respectively actually means. Then you have then the maximum percentage of error in the measurement of x, where x will be. So they have given you the relation for x, which is going to be a square, something that they have given over there, right, will be. So what I'm supposed to find here is what will be the maximum percentage error in this x. So what I'm supposed to find is actually del x divided by x into 100, right? So this will be the percentage error that I'm supposed to find, right? So if I need to find the percentage error, here the relation is such that everything is in like multiplication, division and then the power, right? So multiplication, power, both are just the same thing, right? That is how it is related. So we'll have to add all those relative errors. That's what we are supposed to do. That's what we have seen in the propagation of error part itself. So we'll do that one itself straight away. So in order to get the relative error for the left hand side, which means that x, what I should do is I'll have to add all those relative errors on the right hand side. That is what I'll have to do here. So here if I do the addition of the relative errors, what I actually get is for the first one it is for A, it is like 1%, and the A is going to be like A square. So it will be like 2 into 1, right? So that's how it's going to be. So into 100, obviously. So we'll put it in percentage, because here also you have everything in percentage. Therefore, 2 into 1 percentage. That's what it's supposed to be, right? Okay, you should be clear with this one. Then you have plus the next part is like 2 percentage. So 2 is for the B. So you'll have like half into 2, right? So plus half into 2. So that's the second one. And the third one is that is in division. Still, even if it is in multiplication or in division, you'll have to add it, right? So in addition and then subtraction, the errors get added. It doesn't matter whether it is addition or subtraction. Same way for multiplication and division, the relative error gets added. So it is plus again, right? You should be careful with this stuff. And then C power 1 by 3, you'll have like 1 by 3 into C. For C, I'll put like 3, right? And then you have D, which is going to be 3 into 4, right? So everything is done. Let's do the cancelling out stuff. So when I cancel it out, I'll have like 2, 2, it will get cancelled, 3, 3, it will get cancelled. Then I'll be left with 2. Okay, for the first one, it's going to be like 2. And then for the second term, it's like 1. And for the third term, it's like 1. So you'll have like 2. Again, one more 2. And then you'll have like 12. This is going to be like 16 percentage. That's what you are going to get. So the answer here is like option 3, right? So this too is an easy sum. You should be clear with this one. Let's move on to the next one. Next sum is vernier caliper based sum. Let's see what it is. The main scale of a vernier caliper has n divisions per centimeter, right? So they have given the main scale to be like n divisions per centimeter. In the vernier caliper that we have studied, it is like millimeter scale that we were using over there, which is the main scale. So that's what they have given here, which is going to be like n divisions per centimeter. So in centimeter, if I put it into millimeter, then you have like 10 divisions, right? So instead of 10, what they have given, that is like n divisions per centimeter, okay? So they have given everything in variables, okay? So n divisions per centimeter. Then what they have given is n divisions of the vernier scale coincides with the n minus 1 division of the main scale, okay? So same way, what we will consider is n divisions of the vernier scale. So in vernier scale, from the theory you should know, in the vernier scale, 10 division is going to match with the 9 divisions of the main scale. That's how we've constructed it, okay? That's what they have given here. N division, instead of 10, they have given us n, because in the before statement also I've considered n divisions, okay? So that is how it is. N divisions of the vernier scale coincides with the n minus 1, which means like 10 divisions of the vernier scale obviously coincide with 9 divisions, that is like n minus 1 divisions on the main scale, right? Straight away. Then you have the least count of the vernier caliper. Is what I need to find is the least count of the vernier caliper is something, how it is going to come, in what fashion it is related. That is what I need to find. So the options here also given in variables, right? Okay, so let's take the standard vernier caliper that we have studied and let's try to match, okay, which option suits the best. We get the answer for this question based on analogous situation, right? So let's create an situation over here. We'll see the least count for the vernier caliper that we have seen in the theory part, right? So least count that we have seen over there is 1 divided by number of divisions on the vernier scale. That's what we have seen over there. So it's going to be like 1 divided by number of divisions on the vernier scale, which is like 10, right? So all those units should be represented in millimeter. So you'll have like 0.1 millimeter, because the lowest reading that we could get from the main scale will be like millimeter. Therefore, I'll use that unit itself, right? We have discussed this one exhaustively in theory. Okay, that is why I'm skipping forward. You should be able to understand this one. So you'll have like 0.1 millimeter, right? So if I need to convert this one to centimeter, how should I do it? Like millimeter to centimeter conversion, right? So millimeter and then comes the centimeter, right? So you'll have like extra 1 10 power minus 1 multiplied to it. You'll have like 0.1 into 10 power minus 1 centimeter, right? You should be clear with unit conversions. And then you will have like 0.01 centimeter. This is what the answer should be, right? So I've constructed the vernier caliper the way they have given variables over here, right? So they have given here in terms of variables. Instead here, I just substituted it with the constant value and then I got the answer to be like 0.01 centimeter, right? So same way here in this situation, if I substitute n to be like 10, okay, n divisions per centimeter, that is what I have substituted here as 10, right? Got it? So when I do substitute here as 10, I should get the answer to be like 0.01 centimeter. Let's see, where do I get 0.01 centimeter? That's what I'm supposed to find here. So you have like 1 divided by 10 plus 1, which is like 11 in the situation, 11 into 9. So that doesn't match with like 1 by 100 in this situation, right? 0.01 centimeter is obviously like 1 divided by 100 centimeter, right? You should get the answer to be 1 by 100. That's what we are matching here, cross matching here. So in the first situation, I got like 1 divided by 11 into 9. This will never equate to 1 by 100. So the first one is not the option, right? Okay. So in the second situation, 1 divided by n centimeter, right? So 1 by n centimeter. Here n, instead of n, I will put like 10. So 1 by 10, that's not something that is needed. 1 by 10 millimeter is correct. That is fine. But we need the answer in centimeter, right? So 1 by n centimeter is actually wrong. So because you need to get like 1 by 100. In the third case, you have like 1 divided by 10 into 10. So this case actually matched, right? So you'll have like 1 divided by 100 centimeter. So this thing matched with the new numbers that I have substituted over here. So option 3 should be my answer, right? So let's check the fourth one also. If I do check the fourth one, I'll have like 1 divided by 10 into 11. Obviously, that too will not be my answer, right? So what I did is, I considered the vernier caliper that I studied in the theory part and I matched that numbers with the variables they have given over here, right? So I got the answer to be like 1 by 100 centimeter. Then what I did is, I just took that number, I matched with all those options, okay? So when I matched with it, the option that is going to match with the numbers that I have got will be my answer, right? So in this situation, the answer is like option 3. This is a little bit tricky sum, okay? Anyway, from the little understanding itself, we will be able to do this sum. So we should be clear with this one. Let's move to the next one. Next sum is based on screw gauge. Let's see what it is. A student measured the diameter of a small steel ball using a screw gauge, okay, of least count 0.001 centimeter, right? So they have given us the least count, which is like 0.001 centimeter, right? The main scale reading is 5 millimeter. So they have given us the main scale reading also, which is like 5 millimeter, okay? And then 0 of circular scale division coincide with 25 divisions above the reference level, right? So what they've given here is actually the circular scale coincidence, right? So number of divisions is like 25 divisions, right? So they have given us the main scale reading, which is like 5 millimeter, and also they have given you the circular scale coincidence. So if I multiply it with the least count that they have given over there, I'll get that circular scale coincidence, right? So the thing they have given the next is, if screw gauge has a zero error of minus 0.004 centimeter, right? So this is negative error, therefore I'll have to add it, right? So if it is negative error, I'll have to add it. If it is positive, then I'll have to subtract it, right? So this is something other way around. The correct diameter of the ball is, so I'll have to find the diameter of the ball, right? So I'll have to get the answers out of it, right? So they've given us all those data. What I should do is, I'll have to find the reading that I will get from the screw gauge, right? So here, the first thing that I need to put here is like main scale reading. So what is the main scale reading? That is like 5 millimeter. Obvious, straight away. I'll put it straight away. The next one is circular scale reading. In order to get the circular scale reading, what I should do is, I'll have to multiply circular scale coincidence, which is like 25 divisions in this situation, with the least count, right? So I'll have to put 25 into least count. So least count should be put in millimeters because we are doing everything in millimeters, right? So it's like 0.01 millimeter. Fine. So here I'll have 0.01 millimeter. Okay. And then plus the next one is the error, right? So in this situation, it is negative error. Therefore, I'll have to add it. So if I do the addition, I'll have like 0.04 millimeter, right? Finally, we'll convert everything to centimeter, as if now let everything be in millimeter itself. Okay. So I have like 5 millimeter, and then you have 25 into 0.01, which is like 0.25 plus, and then you'll have 0.04 millimeter. So you will have something like this, 5.29 millimeter. Okay. So if I do the conversion, I'll have like 0.529 centimeter, right? Therefore, the answer is option 4. This too is one of the easiest sum. Let's move to the next one. Next one is also simple sum. Let's see what it is. In an experiment, 4 quantities A, B, C and D are measured with percentage error 1, 2, 3 and 4 percentage respectively, right? The same sum, it's the same pattern sum that you have seen already. Quantity P is calculated as follows, okay? So there we have seen X, here they have given it as P, okay? So P, and then you got some relation, A cube B square divided by CD, percentage error in P is. So what I need to find is percentage error in P. So same logic, okay? So here I'll do it straight away. You should be able to understand this one. So for the first one, you have like A cube. So for A cube, this is in power. Therefore, you'll have like 3 into percentage error in A. So percentage error in A is like 1, okay, and then for the second one B, you'll have like 2% error in B will be like 2, plus for the third one it's like 3, yeah, into 1, so that's straight away, plus, and then for D I'll have like 4, right? So this is the same thing that we have seen, okay, therefore I'm just doing it straight away. You have like 3 plus 4, yeah, so you have like 2 3s and then 2 4s, right? So you'll have like 8 and then 11 11 14. So the answer is like 14 percentage, which is option 3 in this situation, right? So you should be clear with this one. Let's move on to the next one. Next sum is also based on propagation of error. Let's see what it is. A student measures the distance traversed in free fall of a body initially at rest, okay? So it is like free fall, which means initially the velocity was equal to 0, okay, in a given time, right? So we will do all those free fall in the next chapter, which is like motion in a straight line. As if now I'll give you the required formula that is needed for this sum. Anyway, you will know that formula in the next chapter, okay? While we do the next chapter, you'll know that formula. You might have already known in your lower grades. Even if you do not know, it's not a problem. We will do that formula in the next session, in the next chapter, okay? He uses this data to estimate G, right? So he's doing an experiment, and then in order to get the G, he is using those data. Fine. The acceleration due to gravity. If the maximum percentage errors in the measurement of the distance and time are E1 and then E2. So they have given you the percentage error in the measurement of distance, okay, with respect to the distance, and the time is equal to E1 and then E2 respectively. What I need to find is the percentage error in the estimation of G is, okay, so I'll have to find the percentage error with respect to G, okay. The formula that I need here actually is, it's a kinematic equation, okay, which is like S equals ut plus half a t square. Fine, you might have learned this one in your 10th grade itself. Anyway, this is the formula that is required here. So here S is actually the height, okay. So height is something, the error in the measurement of distance is actually the error, okay. So S is actually related to the distance d, okay. Then time is related to this t, and then initial velocity was equal to 0 because initially it was at rest as it is a free fall, okay. So in this situation ut will go to 0. So the first term is not needed because that becomes 0. Then what we have is S equals half, okay. Instead of a, I'll put the gravity, okay, that is acceleration due to gravity is supposed to be put instead for a, so I'll put like g, and then you'll have like t square, right? So if I do the rearrangement, I'll have something like this, g, which is equal to, for s I'll substitute it as h, so I'll have like 2h divided by t square. This is what you'll get, right? When you do the cross multiplication, you'll have g, which is equal to 2h divided by t square, right? Now I have got the relation for the acceleration due to gravity, g, which is equal to 2h divided by t square. So the errors in the distance, which is the height here, is like E1. Same way the error in the measurement of the time will be like E2. So how far the error would have propagated with respect to G, that is what I need to find, right? So percentage error in the estimation of G, right? So we are doing this step just to get that relation. In the previous sum, they have given us the relation straight away. In this situation, they have given us a consideration, and then for that consideration, I should have known the formula. If I do the rearrangement, I'll get that relation, right? Now I have got the relation. So after this, straight away, I'll have to get the percentage error, right? So if I have to get the percentage error for G, it will be like del G by G into 100, right? So the first term that I need to consider here is like h, okay. So there is no any power to it, therefore it will be like straight away, which is like E1. And then the next term that I need to consider is time t. So you'll have like plus 2E2, right? Okay, so it is in division, so you'll have to add it, right? You should know this one. So the answer that I need to get is E1 plus 2E2, which is like option 2 in this situation, right? Okay, so this should be an easy sum, right? If you had known this formula, this should be an easy sum. We'll do this formula in the next chapter, okay? Don't worry about it, but you should be able to understand rest all other things, okay? So let's move on to the next one. Next sum is if the error in the measurement of radius of a sphere is 2%, okay? So the error is something that they have given. Then the error in the determination of volume of the sphere, okay? So they have given us the error in the radius. What we are supposed to find is error in the volume, right? So the relation for the volume of a sphere will be like V equals 4 by 3 pi r cube, right? You should have known this formula. What I need to find here is del V by V, right? So that is what I need to find here. So del V by V into 100, which is like percentage, which I need to find. So it will be equal to 3 into del r by r into 100, that is like 2%, right? So the answer here will be like 6%, right? These are easy sums, you should know. Let's move to the next one. Next sum is taking into account of significant figures, right? So this is one of the sums that is related to significant figures. Taking into account of the significant figures, what is the value of? So you do the subtraction and then you round it off such a way according to the rules that we have studied related to significant figures. Okay, so here it is like subtraction. Okay, so in addition or subtraction, I'll have to consider the least number of significant figures after the decimal places, right? So that is how, after the decimal point. Okay, so that is how I'll consider. So in this situation, for the first one it's like 9.99, so you have like two significant figures after the decimal place. For the second term, you have like four significant figures after the decimal term, right? So the lowest number of significant figure after the decimal point is two significant figures. Okay, so I'll have to round it off such a way I get only two significant figures. Okay, so obviously the answer should be like 9.98 because that is what is rounded off in such a way that you have like two significant figures. Let's do the subtraction and let's cross match it. Okay, so for the first one, I'm going to subtract 9.99 with 0.0099. So that is how I do the subtraction. So we do not know rest two places, so I'll assume it to be 0, 0, 0, right? So if I do the subtraction thing, I'll have something like this, right? So this is going to be like 10, so this is like 1, so this is 0, so this will be like 8, 9.9801, right? So I'll have to round it off to two significant figures. So so this is like 8 and the next number is less than 5, therefore I'll round it off such a way I get 9.98, right? So 9.98 is obviously option 2. Fine. You should be clear with this one. Let's move to the next one. Next sum is based on dimension analysis. We will see what it is. The velocity of a particle at time t is given by, they have given you some relation v equals at plus b divided by t plus c, right? They have given you the relation where a, b and c are constant, right? So a, b and c are constant. The dimensions of a, b and c. So what should be the dimensions of a, b and c? That is what I'll have to find here. This is something that we have seen in dimension analysis, which you should know. Same units, right? So same units can be added or subtracted, right? Whereas different units cannot be added or subtracted, right? So you should know this one, right? So same units and then the different units can be multiplied or divided. With that logic, I'll do the sum, right? Okay. So here you have like b equals at plus b divided by t plus c. So that's the relation you have over here. I'll write it once again. So at plus b divided by t plus c. So here, first let's go in the reverse order. First I'll find the constant for C, then I'll find the constant for B, then I'll find the dimensions for A. As I have already told you, same units can be added, right? So here this is like time. Fine. So T represents time in this situation. They have given over there. So this is time. So obviously she should also be time, right? That unit should also be time. Therefore, that is when I'll be able to add it, right? So this 2 should be in time. That is when I'll be able to add it. Therefore, the dimension for C should actually be capital T, right? So for C, I have got the dimension which is like T. So the only option that is going to match is like option 2. So obviously that will be my answer. Anyway, now I have found T in this situation. Let's find the rest all other things. So what should be B actually? So here if I need to find the value for B, what I will do is I'll consider the left hand side in this situation. So left hand side is the velocity, fine. So the unit for velocity is like meter per second. So you'll have like LT power minus 1, that will be my dimension for velocity. Okay, LT power minus 1. Okay, we will do velocity, acceleration, all those things in the next chapter. Anyway, velocity is something that you need to know. So the unit for velocity is LT power minus 1, right? So the dimension is, right? So here if the left hand side and the right hand side should have the same units, right? Obviously, fine. So these two terms should have same units. That too, left hand side and the right hand side should be same, right? So in the denominator you have the time, fine. Okay, that is that, fine. Then what should be in the numerator? It should be equal to length, right? So that is when I'll be able to equate the left hand side and the right hand side. Therefore B should be equal to L, right? Fine. So here B was equal to L. Now what I found is B, right? Obviously the B was equal to L. Then what I need to find is like A. So in this situation, they have given you the A, but the T is something that it is in the multiplication, right? So the unit of A should be equal to LT power minus 2. That is when TT will get cancelled, and then I'll be able to equate it with the velocity, which is like LT power minus 1. Therefore, the dimension for A will be equal to LT power minus 2, right? So if I do the multiplication, I'll have like, if I do the multiplication with time, so 1 t will get cancelled, and then you'll be left with LT power minus 1. Obviously, this one is also same as the left hand side. As I've already told you, LT power minus 1, LT power minus 1. These two are same units, therefore it can get added, right? So the dimensions that we are about to get here is, for A it will be like LT power minus 2. Okay, for B it is going to be like L, and then for C it will be like T, right? So now we have got the answer to be option 2, right? This is also one of the easiest sum. There are many sums that are related to dimension analysis. Okay, so we will do rest all other sums in the respective chapters, that in the upcoming chapters. Okay, so you do not want to worry about that one. We will do it in the respective chapters. Okay, don't worry about that one. Let's move on to the next one. Next sum is, a screw gauge gives the following reading when used to measure the diameter of a wire. Okay, so they have given us the reading here. Main scale reading is 0 millimeter, right? So you don't have any main scale reading out of it. And then circular scale reading is 52 division. So they have given you the circular scale coincidence. If I multiply it with the least count, I'll get the circular scale reading, right? So here the least count is given that 1 millimeter on the main scale corresponds to 100 divisions. So actually this is like a pitch, right? So for 1 millimeter, I'll be able to get 100 divisions, okay, out of it, right? So 100 divisions on the circular scale. The diameter of the wire from the above data is, right? So what I need to find here is, first I need to know what is the least count. So least count is obviously 1 divided by 100 millimeter. Therefore, it should be like 0.01 millimeter. I know this one straight away. Then in order to get the reading, I'll just add those main scale reading and the circular scale reading. For main scale reading, it's like 0 millimeter. In order to get the circular scale reading, it's like 52 into 0.01 millimeter. If you do the math, you'll have like 0.52 millimeter, right? So here they have given you the answers in options in centimeter. Therefore, I'll have to put extra one more zero into it. You'll have like 0.052 centimeter. Therefore, the answer is option 1 in this situation, right? So these are easy sums. Let's move on to the next one. Next one is statement based sum. Let's see what it is. Plane angle and solid angles have, right? Let's see the options. Both units and then dimension. Then you have like units but no dimensions, right? So this makes sense. So we have seen this one as exceptions in the theory part. So when you cancel out, meter and meter will get cancelled out, right? Therefore, you will not have dimensions into it. But the thing is, thing comes again and again in the physics. Therefore, I have given some unit to it, right? So those units were radian and this t radian, obviously. So this should have units, but it shouldn't have dimensions into it, right? Because length and length will get cancelled, right? So if you are strong in the theory, you'll be able to understand this one. Therefore, the answer for this question is option 2, right? Let's move on to the next one. Next sum is based on significant figures. What they have given here is the area of rectangular field of length 55.3 meter and breadth 25 meter, right? So they have given you the area that I need to find here, and what they've given here is like length and the breadth, which is like 55.3 meter and then the 25 meter, right? After rounding off the value for correct significant digit is, right? So I'll have to find the area and then I'll have to round it off according to the significant figures. Okay, so here I'll have to do the multiplication, right? So in the multiplication, I'll have to consider the least number of significant figure respect to both those conditions. Okay, so here with respect to the first and the second term. Okay, so if I do the multiplication, I'll get something like this. Let's do the multiplication straight away, which is like 55.3 into 25, right? So if I do the multiplication of the length and then the breadth, and then I'll round it off to two significant figures. So here 15, 1, 25, 6, 2, 25, this is like 27, okay? 3 goes 6, 10, 1, 11, okay? So you'll have like 5, 2, 8, 3, okay? So you have like 1, 3, 8, 2, 5, right? So the significant figures are just two numbers because the number with lowest significant figure is like only 2. Therefore, I have to round up the answer to two significant figures. So I'll have to round it up to two significant figures. So if I put the decimal place with respect to the question, I'll have like 1382.5, right? I'll have to round it off to two significant figures, which is like 14, because 3, the next number is greater than 5. Therefore, I'll round it off to 1.4 or 14. Here let me put it like 14 into 10 power 2. Okay, I matched it with the option. Okay, so I have got 14 into 10 power 2. That will be my answer. The option here is option 1. Okay, you shouldn't have any doubt in this one. Let's move on to the next one. Next sum is based on propagation of error. Let's see what it is. A metal wire has zero point 0.4 plus or minus 0.02 gram. Okay, so they have given you the mass, some value, grams, and then they have given you the radius, some value, and then they have given you the length. Okay, so this is metal wire, which means this is in cylindrical shape. Okay, the maximum possible percentage error in the measurement of density, right? So what I need to find is percentage error in the density. So first I need to know the formula for density. Yeah, this is something that we have already known. Density equals mass divided by volume. You should know this one, right? So mass is something that they have given. Let us put it straight away. Instead of volume, I'll have to consider this as a cylinder, right? So if I consider this to be a cylinder, then you will have pi. For volume of a cylinder, it will be equal to the cross-sectional area times the length. Let's consider the length to be L, okay, and then the radius here to be R. So cross-sectional area is pi R square into the length, right? So you should know this one, like cross-sectional area times the length. So cross-sectional area will be equal to pi R square, and then the length will be equal to L. Okay, that is what I have told you. So if I change this equation with respect to R and L, I'll have like M divided by pi R square L, right? Now I have got all those individual terms. Mass is something that they've given in the question. Same way, radius and length is also given in the question, right? Now I'm ready to find the percentage error with respect to the density, right? So what I need to find here is, yeah, del rho divided by rho into 100. This is what I need to find the percentage error with respect to the density, right? With respect to the mass, what I'll have to put here is like del m divided by m. In the previous conditions, in the previous questions, they have given us the value, the percentage error straight away for the right hand side also. In this thing, what is like, I'll have to find that percentage error, which means they have given you the del m separately and the mass also, right? So for relative error, I'll put like del m divided by m into 100 will be the percentage error, right? Del m is obviously 0.002 divided by the mass, which is going to be 0.4, right? For the mass, okay? And then for r, for the radius, it will be like 0.3, right? Divided by, for the radius, it will be like del r divided by r. Therefore, it should be 0.001 divided by 0.3. Fine, into 100. So that is not needed, but here it is like r square. Therefore, I'll have to multiply it by 2. This is something that you need to know. Then you have length, right? So for length, you don't have any powers. Therefore, you'll have 0.02 divided by 5, right? So unit conversion is not needed, and actually it doesn't matter, right? Because if you want to convert this gram to kg, I'll have to multiply it by 10 power 3, right? So again, in the numerator you'll have 1 10 power 3, in the denominator you'll have 1 10 power 3, which will get cancelled. Therefore, I need not worry about this millimeter or centimeter, because anyway I'm going to take ratios from that term itself. Therefore, you do not want to consider the units. Okay, you should be clear. So let's do the math stuff. So if I cancel it out, I'll have 0.4, and then you have like 0.001 divided by 0.2. Okay, for the first one. Here I will not be able to cancel out anything, and then for the second term, that is not possible. Next, if I do the math, I'll get the answer straight away. For the first term, it will be like 1 divided by 200, right? And then for the next term, it's like 2 divided by, if you move the decimal places, you'll have like 300. And then for the last term, it will be like 2 by 500, right? So obviously, all these three terms are relative errors, right? So these three terms are relative error. So if I have to convert this one to percentage error, I'll have to multiply it by 100, right? In the previous questions and all, they have given you straight away those percentage itself, 2%, 3%. But in this situation, what I am doing is I am just first relating it with relative error, which means with respect to unity. Then I'll have to convert it to percentage error. So obviously I'll have to multiply it by 100, right? You should be able to understand this one. So I'll multiply it with 100 to convert it to percentage error. So now left hand side and right hand side are with respect to percentage error, right? So even if you do this one straight away, you'll get to know, right? So this is with respect to percentage, and then you'll get 2 decimal places ahead. Answer will be something like that, right? So obviously it will be clear that you'll have to multiply it with 100. Okay, so when you do the multiplication, all those zeros will get cancelled, and then will just be left with 1 by 2 plus 2 by 3 plus 2 by 5. Okay, so now if I solve this one, let's do with the decimal places itself. You'll have like for 1 by 2, I'll be able to substitute it as 0.5, right, half. And then for the next term, for 1 by 3, it will be like 0.33. Here it is like 2 by 3. Therefore, it should be 0.66. Okay. And then for the next term, 2 will not cancel out. Therefore, you'll have to put 1 0. And then it will be like 0.20. So with respect to 4, it just cancel out. Therefore, you'll have like 0.4. Fine. So now I have got all those terms. If I just add it, I'll get the percentage, right? So if you do the addition, 0.5 plus 0.4 is actually 0.9. Then if I add like 0.6 to it, it will be like 1.5, right? So you'll have like 1.56. That will be my answer, 1.56 percentage. Therefore, the answer here is 1.56. If I round it off, I'll get 1.6 percentage, right? Okay, the answer is option 3, right? You should be clear with this sum. You shouldn't have any doubt into it. Here, the only trick that they have played here is they have asked us to find out the percentage error. Okay, even in the left hand side, they didn't give us the percentage error straight away. We'll have to find it out. The thing is easy, right? Del m divided by m. You'll have to put the change in error in the numerator divided by the real value, which means a mean. That will give me the relative error. Then if I multiply it with 100, I'll get the percentage error, right? Then you do the solving and get the answer, right? You shouldn't have any doubt in this one. Let's move to the next one. This is the last sum of the session. That too is a statement based sum. Let's see what it is. The error in the measurement which arise due to unpredictable fluctuations in temperature and voltage supply are, right? So we have like fluctuations due to temperature and then the voltage supply, right? These things cannot be controlled. Therefore, obviously, there should be like random error, right? Instrumental error is something that we could control. Personal error, that is a mistake done by us. Least count errors that could be rectified. But this thing, temperature, surrounding temperature and then the voltage fluctuation cannot be controlled. Therefore, that thing falls into the category of random errors, right? So this is a kind of statement based sum. So this is the last sum that you should know in this chapter, right? You should be clear with all those sums that we have discussed, right? There are only around 14 sums from this chapter, right? So you have questions from dimension analysis. As I've already told you, we'll do that one in the respective chapters, okay? So you should be clear with all these sums that we have discussed. Theory part in itself is exhaustive, but the sum part is actually easy in this chapter, right? Fine. So with this, the video gets completed. Bye.